Good afternoon, everyone. My name is Uma Maheshwari. We will be here discussing about the peripheral interfacing technique in the topic of 8051 functional block diagram. In this one, the interfacing requirements are the purpose of the communication with various input and then output devices, and peripheral devices are found to be a tremendous use of a system designer. How come it has been used in a system designer usage? Here, the IRS, that is the interface requirement specification, is the name. By some other name, it specifies the requirements it has been given in the external interface, say for example remote control, and then in temperature data something and all, and these interface requirements have the same status as many as the other requirements. Say for example, here these represents the characteristics required by any of the solution. For that solution it should be acceptable one. The requirements are owned by the same owner as of the other system requirements. Say for example, here if we want to control any of the system like temperature control or soil moisturizer, for that and all we need an interfacing technique. For that, the interfacing, how come the interfacing will be there? The interfacing will gets connected with the two things, like the sensor network is on the other side and your main microcontroller will be in the another side. So these interfacing technique is the most important one to do to complete an application. So in this interfacing document, this is also called as an IRD. Here it defines the functional and then performance, electrical, environment, human and then physical requirements and constraints that exist at a common boundary between two or more function system requirements. Here the general purpose devices which has been used here, or it has been used for a variety of input output devices to the microcontroller. Here this simple input and output is PPI, that is the programmable peripheral interface, that is been from A to A55. This is the IC number. And programmable interrupt controller, programmable DMA. DMA is nothing but direct memory access. That is, you can, if your memory is not in a way to store something, means you just want to external, if you want to just connect the external thing, means it has been used, that is the programmable DMA controller has been used. This programmable communication interface and programmable interval timers. Here in this case, the here the microcontroller unit, it is a small computer on a single interrupt circuit that is being designed to control specific task within an element. That is, a typical microcontroller consists of a processor core, volatile and the non-volatile memory, etc., input output peripherals and the communication interfaces and all. So this memory is also used to store data and then program code, while the input output peripherals are used to interact with the external devices. Here the special function devices, which is also used to communicate with the other one. So this is also called as a peripheral devices. Here in this case, like in the special function peripherals, these are, if you recall from other discussion, like in the memory organization and all, this internal RAM and then ROM of, or the data memory of 8051 microcontroller is categorized into, here the general purpose registers, bit addressable registers, register banks and SFRs. These this SFRs, sorry for this SFRs are nothing but, the SFRs are essentially in programming and managing various hardware requirements, that is the hardware peripherals such as timers, serial ports, input and output ports. By here in this, the manipulating these registers, one can effectively modify the operating modes of an 8051. Here, in order to effectively monitor the control the 8051 microcontroller, the special function registers are the tremendous one which has been used in the case of either in the transmitting side and also as well as in the receiving side. So in order to effectively As we have observed from the internal RAM structure, the address spaces is allocated to the SFR ranges from 80H, that is 80H to FFH, and the total memory of 128 memory locations. However, out of these 128 locations, within this unique name, 1 byte address, that is the SFRs, 1 byte address of the specific purpose. In this one, you can access them in the same way as you could access the internal RAM. The only difference is like 00 to 7FH is the a memory allocated to the SFRs, that is for special function registers. Here we will see what is the main assessment thing. What is the main purpose of special function registers in 8051 microcontroller? To store program code, or to store the data for calculations, or for used for peripherals and internal functions, and for stack pointer. And what is the address range? I told you, like 00 to 7F. And which operation are performed by the bit manipulating instruction of Boolean compressor? The next one is, which of the following SFR is used to control the timer and then control? Here in this case, TCON is the one, and P0, SCON, and then DPTR is the data pointer, and TCON is the timer control unit, and SCON is for serial communication one. And P0 is nothing but your simple port P0, P1, P2, and P3. Here, what is the role of TCON register over here? Whether it is a true or false, you have to answer. SFRs can be accessed as bits, bytes, or words. The address space for SFRs overlap with the internal RAM. The PSW register contains flags that indicates the status of the microcontroller. Here, this can be your classroom activity. Just find it out. Thank you. We'll see the next topic in the next video.